Right. Now this is section C of this paper, and it says we're supposed to find the limit as x approach 2 of x cubed minus x squared over x cubed minus 8 over x squared minus 6x plus 8. To do this question easy, so I want to find the limit as it's a x is approaching 2 of x cubed minus 8. I want to change the color, but I'll just work with the burgundy for now. Over x squared minus 6x plus 8. So as I said, there's two ways you can do it. You can do it by factorization, or you can do it by L'Hopital's rule. I love to do it the two-way. So just writing it the two-way them. Any way you want to do it is fine. Limit as x approach 2 of x cubed minus 8 over x squared minus 6x plus 8. All right, so either way is perfectly fine how you want to do it. Now, let's say you're doing it L'Hopital's rule. This will just become the limit as x approaches 2 of. When you differentiate x cubed minus 8, you get 3x squared. And when you differentiate x squared minus 6x, you get 2x minus 6. Then you can plug in x as 2. Plugging in x as 2, you get 3 times 2 squared over 2 times 2 minus 6. And that would give you the answer. That is 2 squared is 4. 4 over 3 is 12. 2 times 2 is 4. 4 minus 6 is negative 2. 12 over negative 2 is negative 6. Now let's say you're doing it by factorization. Let's do factorization in black. That would be the limit as x approaches 2 of. Remember that 8 can be written as 2 cubed. So by factorization, you can factorize it and get that this is x minus 2 times, just to show you how I get that, 8, remember, can be written as 2 cubed. So x to the n minus a to the n, in this case it's x minus 2 times x squared plus 2x plus 2 squared, and 2 squared is 4. Then the denominator can be factorized to give you x minus 2 times, in bracket, this is x squared, signs are different. This one minus, so over here have to be plus. Is that what, plus 4? Let's look at this. This times this is x squared. This times this. No, this can't be plus 4 if that is minus 2. Did I write down the question right? Let's check it out. Yeah, write it down right. So how do I factorize this? Having issues factorizing. If this is the 2, to cancel out the 2. Let me see, to cancel out the 2. But it can't be 4. What number should be here to factorize this? Which two number times them will get minus 8? But when we add them, we get negative 6. Which two numbers are that to get negative 6? And we need it to be 2 and something. And that number I need to times it to get. So to factorize this, I think I'm making a slight mistake. I think this should be minus 4 too. Minus 4. Let's see if that works. Yeah, on Mondays, my factorization skills not so good. Yeah, one of them things. But x minus 2 cancel this. Now we can plug in x as 2. Now we're good. Plugging in 2, you're going to get 2 squared, which is 4, plus 2 times 2, which is 4. And then plus another 4 over 2 minus 4, which is negative 2, you get your 12 over negative 2, which is negative 6. So any way you want to do it, you see so the answer negative 6. Easy. So if you want to do it method 1 or you want to do it method 2, the answer is negative 6. Nice. Either way, negative 6. So 5 marks for that. Now this question says, it says the function is defined by 3 minus x, and it says it is 3 minus x when x is greater than or equal to 1, and it is 1 plus x when x is less than 1. And it says sketch the graph for this function on this particular domain. Now, I'm not going to sketch the graph. What we're going to do is we're going to open the geometer sketchpad and draw this graph. Yeah, man. We're going to actually draw the graph. All right. So let's go to geometer sketchpad right here. All right. So we're going to insert this graph. Let's insert the grid form first. Now, the first thing it says is that 3 minus x is when the function is greater than or equal to 1. So when x is 1, you know that this would be the point. 3 minus 1 is 2. So when x is 1, y is 2. Let's put that. Wrong page. When x is 1, y is 2. When x is 1, y is 2. Then you also know, say, 3 minus x when x is 2, y is 1. That's 3 minus x. That's how the graph behave right there. Then them tell we say, the next set of points them is when x is less than 1, it's 1 plus x. So when x is 0, 1 plus 0 is 1. So we'll plot the point 0, 1. Why do I keep come back here? 0, 1, 0, 1, which is right here. Then when x is minus 1, 1 plus x, 1 plus minus 1 is 0. So you have minus 1, 0. We have no more to plot? No more to plot. All right, so that's it. All right, so we'll plot all the points there. So good. So now we just need to connect them. So show you how the function behave. This is a sketch of it. This is a sketch of f of x. This is a sketch of f of x. All right, so we'll call it this. This is f of x. Now what do we need now? It says that, so that's f of x on the graph that we have right there. Just to look back at it one more time, this is our f of x, this graph right here. That's our sketch. Next thing now it says to do is evaluate the limit as x approach 1 from the right. The limit from the right is going to be when you plug in 1, when x is bigger than 1. So that's 3 minus 1, which is 2. Find the limit as x approach 1 from the left. Say plug in 1 on this side, 1 plus 1, which is also 2. Since the limit from the left is equal to the limit from the right, the function is continuous. So you can tell them, deduce that f of x is continuous, that at x equal 1. You tell them yes. So what you tell them is, at x equal 1, at x equal 1, there are 3 conditions for continuity. First, f of 1 must be defined. We see that f of 1 is equal to 2, which is defined, so condition 1 is satisfied. Condition 1 satisfied because f of 1 is defined. So you got 1 mark out of the 3. Condition 2 is that the limit must exist. We see that the limit as x approaches 1 of f of x exists. The limit as x approach 1 of f of x, it exists, and it's equal to 2. And that's because the left-hand limit equal to the right-hand limit. That's condition 2. And then finally, condition 3 is that the limit is equal to f of 1. So since the limit as x approach 1 of f of x is equal to limit as x approach 1 of f of x, since this is indeed equal to f of 1, which is equal to 2. Hence, the function f is continuous at x equal 1. Hence, the function f is continuous at x equal 1. That's it. Easy, soft, with a capital T. Hence, it is continuous at x equal 1. All right, no problem. Nice. Next thing now is that it says differentiate from first principle with respect to x the function y equal 1 over x squared. So you have the function right here, y equal 1 over x squared. Y is equal to 1 over x squared. And we need to find out what is f prime of x from first principle. So remember first principle formula, let's write it in black. First principle formula tell us that dy by dx, remember, is equal to the limit as h tends to 0, the limit as h tends to 0 of f of x plus h minus f of x over h. This is limits from first principle formula. So since this is what we have, so since this is what we have, we know that dy by dx is going to be equal to the limit as h approaches 0 of f of x plus h is going to be 1 over x plus h all square minus f of x, which is minus 1 over f of x. F of x is x squared, and this is being divided by h. Nice. So now we just need to simplify this right here. Simplifying this, what we're going to get is I can multiply up x squared, multiply up x plus h, and write it as one fraction. Yes, write it as one fraction. Please to do so. So this gives us the limit as h approach 0 of x squared minus in bracket x plus h all square over x squared times x plus h all square. That's what the numerator works out to be. And all of this is being divided by h. Now look at this. If this is being divided by h, remember if you have a fraction a over b being divided by c, it is the same as a over b times c. So what am I trying to say? I'm saying that we can write all of this as one fraction. Why not write everything as one fraction? So we can end up write all of this as one fraction to say this is the limit as h approaches 0 of, writing it as one fraction, it is x squared minus in bracket x plus h all square divided by this part, put the h up here to write x squared times h times x plus h all square. Yeah, man, that's what we can put up there. What does that do for us? This then tells us that dy by dx is indeed going to be equal to the limit as h tends to 0 of, expand out the numerator. Expand out the numerator, we're going to get x squared minus, now you see x plus h all square when you expand it, it's going to be x plus h all square is x squared plus 2xh plus h squared. Nice. And so this is now over x squared times h times, this is x plus, this was what, x plus h all square. All right, cool. Now simplifying this now, we're close to finding dy by dx. We're almost there to find dy by dx. So I'm going to write now, this is now the limit as h approach 0 of x squared minus x squared, that gone. Then minus 2xh, we're going to get minus 2xh. Then you're going to get minus h squared when you expand in the minus. Yeah, man. Over x squared times, put back the h right there, times x plus h all squared. Now we still can't plug in h yet, because if you plug in h, you're going to get 0 over 0. What do? Factor out the h from the numerator. So we're going to get the limit as h approaches 0 off. Factor out the h. You're left back with minus 2x minus h, over, factor out the h. You're going to have h times in bracket x squared times x plus h all squared. That's what we end up with. Nice. So since this is what we end up with now, are we good? We notice that h here, cancel out that h there, so can plug in h as 0 now. You're going to get minus 2x over, plug in h as 0 now. Down here, so you get x squared times in bracket, this is now x plus h is 0, so it's x plus 0 square. So we end up get, this is now minus 2x over x squared times x squared is x to the 4. And then x over x to the 4, that cancel out the x to get minus 2 over x cubed. So that's how you do this question. Easy, soft. That would be the answer, soft. Soft with a capital T. Yeah, man. Now, of course, we love to verify. Now, all I'm going to do is verify it. Because remember, y was 1 over x squared, right? If y is 1 over x squared and we were to differentiate it, we'd have to rewrite y as x to the minus 2. And if we rewrite y as x to the minus 2, then dy by dx would be equal to, that look like minus 2x to the minus 3. That would be dy by dx. So this would be minus 2 over x cubed. That would be dy by dx. All right, cool. So that's dy by dx. All right. So yes, we'll see that we get the same thing. So when we differentiate it and we use first principle, we get the same thing, so we know that we're correct. So that's this one right here. Nice. Now the next question right here says, the function f of x is such that f prime of x is 3x squared plus 6x plus k. So let's write that down. I'm just going to write that down. Then give one function and then tell us say f prime, meaning the first derivative, f prime of x, then tell us that this is equal to 3x squared plus 3x squared plus what? 3x squared plus 6x plus k. That's what they tell us. All right, so we'll write down that first. Good. Write that on your paper. Next thing to do is then tell us that f of 0 is negative 6. F of 0 is negative 6. But this is f prime. But just to write down that information, f of 0 is negative 6. This going to come into play some point, not right now. Next thing to write down is that f of 1 is minus 3. F of 1 is minus 3. All right, so f of 1 is negative 3. Okay, no problem. So we just need to work, we just need to find out what is k, right? Just need to find k, that's all. Find the function f of x. Oh, we need to find the function, not just k. So the first thing we know is that since f prime of x is this, we have to integrate this to get f of x. That's the first thing we need to do. Integrate, all right? So let us integrate now f prime of x to find f of x. So you can tell them that this is going to be f of x. F of x is going to be equal to the integral of dy by dx, which is the integral of 3x squared plus 6x plus k. Yeah. You integrate this. Yeah, man, you integrate this dx. By integrating this now, what we're going to end up get is 3x cubed over 3 plus, this is going to end up being now 6x squared over 2 plus, this is then k times x, yeah, k times x, plus some constant c. So that is f of x. This is now f of x. Yeah, man. But now, in order to find the function f of x, you need k and you need c. Now, I'm just going to cancel out some numbers. This 3 cancel this 3 right here. And this 2 into itself 1, 2 into 6, 3. So literally what I'm saying is we know that f of x is equal to x cubed. F of x is x cubed plus 3x squared plus kx plus c. This is f of x. All right, cool. So we just need to find the constants k and c. Now it told us that f of 0 is minus 6. F of 0 is equal to negative 6. And so what does that mean? If you plug in 0 in this function, that implies that when y is minus 6, 0 cubed is 0, plus 3 times 0, plus k times 0, equal minus, well, plus c equal negative 6. So that clearly then just a tell we say c equal negative 6. Yeah, man. Now let's plug in when x is 1 now. When x is 1, when x is equal to 1, right, we can plug 1 into the function. And when x is 1, we know that the y value is negative 3. So when x is 1, we set up the equation minus 3 is equal to, plug in when x is 1, 1 cubed is 1, plus 3 times 1 squared, that is 3, plus k times 1 is k, minus 3. Yeah, that's our equation. So we realize that 3 plus minus 3 gone. So end up get minus 3 is equal to 1 plus k. Yeah, man. And so all we need to do now is subtract 1 from both sides. And so k is negative 4. Since k is negative 4, you can write down your function f of x now. So this is your answer. You can tell them that f of x will end up be equal to x cubed plus 3x squared plus kx, which is really minus 4x. Yeah, and then you write plus your c, and your c is minus 6. And that's your answer. All right, nice and easy. Soft, the capital T. Nice. So that takes care of question 5. That's it. That's the function f of x. I have one last question to do and we're done. It tells us that question 6, y is equal to sine 2x cos 2x. Show that d2y by dx squared plus 4y is 0. So y is sine 2x plus cos 2x. All right, so y is equal to sine 2x plus cos 2x. Yeah, man, this is y. So now we just need to find dy by dx. To find dy by dx, we differentiate. So dy by dx is equal to, when you differentiate sine 2x, you get cos. So you're going to end up get 2 cos 2x. Plus, when you differentiate cos, you get minus sine, so you get minus 2 sine 2x. All right, so this is going to be dy by dx. Now you need to find d2y by dx squared. d2y by dx squared, when you work it out, what you're going to get is, when you differentiate cos right here, you get minus sine, so you're going to get minus 4 sine 2x. Then when you differentiate sine, you get cos, so it's going to become minus 4 cos 2x. That's what you're going to get. All right, nice. So this is what we end up get. Now that we end up get this now, all right, now that we end up get this, all we need to do now is to just do the proof. So the proof was to show that d2y by dx squared plus 4y is 0. So now let's look at this now. So now d2y by dx squared plus 4 times y, we can tell them no, this is equal to, what is d2y by dx squared? d2y by dx squared is your minus 4 sine 2x minus 4 cos 2x. Then you need plus 4 times y, and y is a sine 2x plus a cos 2x. But if you stay so now, boom, and you expand that, expanding this, you're going to end up get what? Minus 4 sine 2x minus 4 cos 2x, and then plus 4 sine 2x plus 4 cos 2x. But guys, look on that. Look at that right there. So you see the sine and the cos, them they cancel each other. Yeah, the sine there, so this and this are 0, and this are 0. So you get 0 plus 0, which is just 0. So see it there, proven. They're giving away 6 mark. It's Christmas. That's d2y by dx squared plus 4y. They're literally giving away free marks. Yeah, man, they're literally giving away free marks. All right, they're giving away free marks. We're nice. We're nice, nice, nice. All right, nice. Now, the next question here says, given that the integral, I know it's hard to see, from 0 to a of x plus 1 is 3 times the integral from 0 to a of x minus 1, find the value of a, where a is positive. So they tell us that the integral from 0 to a of x plus 1 dx, they tell us that it's equal to the integral from 0 to a of, they put a 3 right here, of x minus 1. We need to find a. All right, so let's find a. So to find a now, first thing that we need to do is, of course, integrate both sides. Integrating x plus 1, you get x squared over 2, plus when you integrate 1, you get x, and we'll plug in from 0 to a, and that's equal to 3 times, in bracket, when you integrate x minus 1, you get x squared over 2 minus x, and you plug in from 0 to a. Now let's plug in a now. Plugging in a, you're going to get a squared over 2 plus a, and that's equal to 3 times, in bracket, when you plug in a on this side, you get a squared over 2 minus a. Now you might say, sir, when you plug in 0? When you plug in 0, you get minus 0. So if you want to put minus 0 and minus 0, that's fine. So this is all we're simplifying. Let's finish it off over here. Simplifying that, you have a squared over 2 minus a, well, plus a, sorry, is equal to 3a squared over 2, and this is minus 3a. So I need to bring everything to one side. I can multiply through by 2 first, because I don't like to work with fractions. Maybe you're a little bit better than me, but I'm not good with fractions all the time. So if I multiply through by 2, I'll get a squared plus 2a, and that's equal to, this is going to become 3a squared minus 6a. So what can we do next? We can, of course, bring over a squared over here to get this is going to be 2a squared. Yeah, man, 2a squared. Then we can bring over 2a over here. Minus 6a minus 2a is minus 8a. And this is what? Equal to 0. Yeah. We can then divide through by 2 again, one more time, to get a squared minus 4a equals 0. Then we can factor out a. I'll have a times a minus 4, and this is equal to 0. And so what we end up getting is a equals 0 or a equals 4. A equals 0 or a equals 4. Since a equals 0 can't work, because them tell we say a is greater than 0, the final answer is a equals 4. That's it. Guys, you see how math's nice, you know. Imagine you start out with all of this and end up with this. Math's nice, you know. End up with a equals 4. That's how nice maths is. We end up just with a equals 4. Yeah, man. So now, right here, so now, we have that it said the diagram below, not drawn to scale, shows piece of a thin cardboard 16 centimeter, and it is piece of a cardboard 16 centimeter by 10 centimeter. The shaded squares each of the side x centimeter are removed from each corner. It said the remainder is folded to form a tray. So then remove them part here to form one tray. So why would you need to remove it? I don't know. Let's find out why. So they decide to remove it. Yeah. Let's find out why now. All right. So it says that show that the volume of the tray is this. So remember that we remove them part here. This, and this get removed. So let's look at how we're going to find the volume of the tray. So to find the volume of the tray, we have to consider that we remove this. All right. So now the diagram represents a piece of thin represented by this, and it says the shaded square each represent x centimeter are removed, and the remainder of the tray, the remainder is folded to form a tray. So this part right here, so is used to form a tray. Right, so if we're going to use this to form a tray, I just want to give you an idea, like a schematic of how the tray look. We can take out this piece. It's like you fold it up. How can I get this, man? It's like we fold it up. I'm not so good, but I'm actually going to give a little diagram, right? It's like, let me see, it's like you have a flat line now. Like this is a tray, right? And instead of piece where them fold up, the piece where them fold up, you push it up here, so push it up here, so this piece right here, so and this piece right here, so then fold it up. This is a tray, and it lock in now. So you fold up that piece there too, fold up that piece there too, and this is like a tray, right? I know this is a 2D representation, it don't make no sense. I don't know how I'm trying to show you, but yeah, this is a tray. So now we know how to find volume, right? So we know that volume is equal to length times width times height. Volume is equal to length times width times height. All right, that's how we find volume. So now, this right here, so to find the volume, we need the length of our tray. This is the length of our tray, 16. All right, this is the length of our tray. Area of the cross section times the height. Area of the cross section, this is 16. This right here is x, and then the height of the tray is the 10. All right. All right, let me go back on this. I just want to share this one more time. All right, so this is now. So because I can't really give a 2D sketch, I'm gonna try to give like a 3D, well, No, I can't give a 3D. My apologies. I'm just going to try to give you a representation of what is happening. So this is the container, and they tell us the whole of this is 16. So if that side here is x and that side here is x, then that means that the remaining piece in the middle right here is 16 minus x. This is going to be the length of your tray. Then this side right here, so now is when you fold it up, this gonna be like the width of the tray, if that makes sense. This right here is gonna be the width of the tray. So that is length of 16 minus x. Then the little x there gonna be the width of the tray, this little x. Then the height of the tray is this side right here. But if this is x and this is x, and the whole thing was 10, then another piece here is 10 minus 2x then, in order for the whole thing be 10. Because remember, the whole thing is 10. The whole side here so is 10. So that means so we can tell them that the height is 10 minus 2x. So that is volume, length times width times height. So now we're going to work out this and hope set equal to what they want. So the volume is x times, let's expand in this right here. The quadratic, 16 times 10 is 160. 16 times minus 2x is minus 32x. 16 times 16 times 10, 16 times minus 2x, minus x times 10 is minus 10x. Then minus x times minus 2x, that's plus 2x squared. Let's simplify this now. Simplifying inside this now, I am getting that the volume is x times, in bracket, 160. Let's start with the x squared term, that is 2x squared. And then right here, so now minus, that's minus 42x. And then I see that right there, so now I have plus 160. Yeah, so this is what I get for the volume. Is that what they want? X cubed minus 13x squared plus 40x, 13x squared. Did we multiply properly? Let's go again. 16 times this, 16 times 2, x times this, x times this. Shoot, we made a slight error. If this piece here is x and this piece here is x, I made a blemish right here, then this piece should have been 16 minus 2x. I gave it away. This should have been 16 minus 2x. So this would have been minus 2x times 10 would have been minus 20x. And this would have been minus 52x. All right, so I'm giving it away. This would be the volume now. And so the volume would end up be equal to x times this is just 2x cubed. Yeah. This times this is now minus 52x squared plus 160x. I know. This is not 52. I'm going to fix it. I am going to fix it, guys. Don't worry. I'm going to fix it. 52x squared. Now, this is the volume. Now, what you can do is, now the 2x times the 2x was supposed to make it become 4x squared. So I have to fix that too. 4x squared. So you can't make the bag of calculation mistake. That's 4x cubed now. So now you can factor out the 4. Factor out your 4. You end up getting your x cubed minus your 13x squared plus your 40x. So now we're done. Nice. So that's now your volume. Soft. Yeah, man, soft. Give it 6 marks. They should be about 4. Soft. About 4 marks. That should be about them. Give it 6. So we're nice. So that's the volume. Or they give it 5. They say, hence find the possible value of x such that the volume is minimum. Now, if the volume is minimum, we know, so if the volume is minimum, then the first derivative is 0. Remember, in module 3 is differentiation. V min implies dV by dx equals 0. dv by dx equals 0. So you're going to differentiate the volume formula. So I differentiate 4x cubed to get 4x cubed. When I differentiate, that is 12x squared minus, when I differentiate 52x squared, I get minus 104x. And then when I differentiate 160x, I get plus 160, and this is equal to 0. All right, this is equal to 0. So now what I then do is divide through by, maybe we want to divide through by 4. I don't know. Let's see. If we divide through by 4, does this help? This will then be 3x squared minus 26x plus 40 equals 0. All right. And so now we just need to solve for x now, guys. This look hard to factorize now. Yeah, man, then big number here, man, 40, come on. But now we know, so it's going to be 3x and x. Signs are the same on both of them, negative. Which two number we times them we get 40, but add them we get 26. 10 and 4, no. Let's see. 8. 3 8's 24. And 5, that don't work. I'm having a difficult time factorizing, so I'm just going to go to my quadratic formula. Yeah, man, it's sad, but I have to go to the quadratic formula. The quadratic formula is minus b, which is going to be 26 plus or minus, so plus the square root of b squared, which is 26 squared, minus 4ac, minus 4 times 3 times c, which was, I think c was 40. That's being divided by 2a, which is 2 times 3, which is 6, 20 over 3. So I get 20 over 3 is one answer. And then with the minus, or to put a minus, the next answer would be 2. Come on, man. How did I not see it's 2 and 20? That's so sad. 2 and 20. All right. So that means these are the two x values. 20 over 3 and 2. Now notice I get 2x values. So in order to determine which one of them the volume would be minimum, we need second derivative. We need d2y by dx squared. In this case, it's not d2y, it's d2v by dx squared, because this is going to determine where is minimum. We know when d2v by dx squared is greater than 0, that's when it's going to be a min. All right, so we need to find which one of them, d2v by dx squared, is greater than 0 for min, just to bear that in mind. So now finding d2v by dx squared, d2v by dx squared, it's going to be equal to, we differentiate dv by dx to get, carry down the 2, we get 24, x minus 104. So now if you plug in x equal 20 over 3, so you notice at x equal 20 over 3, that is where d2v by dx squared will be greater than 0. At x equal 20 over 3, d2v by dx squared is greater than 0. If you don't see it and you really want me to show you, look, put 20 over 3 for x here. Put 20 over 3 right here. So that's, if you put 2, it's less than 0. If you put 20 over 3, it's going to be greater than 0. So this is when the minimum occur. All right. So the volume is minimum when x equal 20 over 3. That's when the volume is minimum. So we can tell them that the volume is minimum when x equal 20 over 3. So now we can actually find the minimum volume, because that's what we were initially asked to find. Oh no, we're done. I think they just wanted the value of x for which it is minimum. See there, we're done. We're actually done. Like legit, we're done. Find the value of x for which it is minimum. So in this case, we'll find that x equal 20 over 3. We're nice. Yeah, man, we're nice. Nice. All right. Yeah, man, we're good. That's it. 2008 done. 2008 literally done. So I hope we had lots of fun. Realize that them pure maths paper are really easy, right? And just stay tuned for more and keep on practicing for your exam. All right. Make sure to subscribe to help the channel grow, and I wish you all the best prepping for your exam. Nice.